You know, sometimes you look at a beautifully written line of code and it feels simple, natural, almost effortless.
Yeah.
But what if that feeling of ease, that flexibility we love, actually hides some incredible, maybe even devilish complexity underneath?
That's often the case, isn't it? The
Yeah.
more natural something feels on the surface,
Yeah.
the more sophisticated the engineering kind of has to be behind the curtain to make it all hang together.
Exactly. And that hidden complexity is precisely what we're peeling back the layers on today.
Mm.
Welcome to the Deep Dive, where we're plunging into the fascinating and sometimes surprisingly intricate world of how programming languages, specifically Ruby, are actually built their grammar and syntax structures.
And this isn't just, a general wander through language design. This deep dive is built on a specific source you provided us.
Right.
It's excerpts from a talk given by Yudai Takada, known as YDAH, at Ruby Kaigi. He's a Ruby committer and part of this great-sounding group, the LRR Parser Gangs.
Love that name.
Yeah.
So our mission with this material is really to unpack YDH's insights.
Okay.
We want to understand what grammar and syntax truly mean in the context of code, why defining Ruby's famous flexibility is such a challenge at this really fundamental level, and how experts like YDAH are working to literally reconstruct and, well, improve the very tools that define the language itself.
And definitely stick with us, because while this might sound like, deep compiler theory.
Yeah, it could sound intimidating.
Right. But understanding the foundations, how a language understands itself, it can totally shift how you see the code you write or debug every day.
Absolutely. So we're here to be your guides through the source material.
Let's do it.
Okay, let's unpack this talk. First off, who is Yudai Takada, based only on what the source tells us?
Okay, so according to the material, YDAH is a backend engineer at Andopad.
Huh?
And interestingly, he became a Ruby committer fairly recently, December of last year, it says.
Oh, wow, yeah. That's quite recent. And the talk really highlights his work directly on the core plumbing, right? Parser generators and parsers.
Exactly. He specifically mentioned working on adding location information to nodes using ParseY.
ParseY.
Yeah, and also refactoring ParseY itself. The source is he's part of ParseY, which is apparently a 5-member organization.
Gotcha. And he's been working with, the talk calls them Yamano committers, which probably means the Ryama committers.
Seems likely, yeah. Working with them on adding support for features like inline parameters and these syntax diagrams for Ryama, the Ruby parser generator.
Okay. And he's also active in the community.
Yeah, hosting Kyobashi Ruby in Osaka.
Yeah.
And he included a little announcement in his talk, too. The Kansai Ruby conference was planned for June 28th in Kyoto. The CFP deadline was May 7th, according to the source.
Right, so really connecting that deep technical work back to the broader community.
Definitely.
Okay, great. So let's dive into the technical heart of his talk. YDH starts with the really fundamental stuff. What does he mean by grammar in this programming context?
Well, he starts with the everyday idea first. Grammar is about combining words so they make sense.
Like English grammar.
Exactly. Like a design drawings rules, or maybe traffic rules for communication. The point is conveying intentions accurately.
Okay, communication rules. How does that translate to programming languages?
There, he defines it more formally. Rules for writing commands for calculators, essentially.
Right.
In any language, whether human or code, really has these two key parts, syntax and semantics.
Ah, yes. The classic pair. Syntax versus semantics. How does he break that down for us?
Okay, so syntax is all about the rules for putting things together. Words, symbols, keywords, that sort of stuff.
The structure.
Right, the structure. And this gets checked before you even try to run the code. If you mess up the syntax, the computer just can't understand it. Syntax error. Game over.
Got it. Form and structure. And semantics.
Semantics is about the meaning, what the program is supposed to do, and its actual behavior when it runs.
So what it does.
What it does, exactly. A semantic means your code might look right syntactically, but it doesn't do what you intended. That's where you get bugs, logical flaws.
And he uses that brilliant example from linguistics, right? Colorless green ideas sleep furiously.
It's perfect, isn't it? Because, like he points out, that sentence is totally fine syntactically in English. Subject, adjective, noun, verb, adverb. Checks out.
Looks okay.
But the meaning, complete nonsense. Green things aren't colorless. Ideas don't sleep, and certainly not furiously.
Yeah, it really nails the difference. Structure, syntax, can be fine even when the meaning, semantics, is just gone.
Totally.
And the focus of YDH talk and our deep dive today is really on those syntax structures. What exactly are we talking about there?
We're talking about the pieces, the building blocks of the code. Things like strings, individual tokens like plus or if, keywords,
Okay.
and then the rules, the specific ways you have to combine those pieces to make meaningful parts, like formulas or method calls or class definitions.
And the standard way to write down these precise rules, the order of things, where keywords fit, how formulas look, that's often using something called BNFs.
Right, Backus-Naur form, BNF. It's a formal notation pretty widely used in computer science to define these syntax structures clearly and unambiguously.
Okay, so this brings us right to the core of defining Ruby's syntax, this file called parser.y.
Exactly. Parser.y is the file that actually contains these BNF-like rules.
Yeah.
It defines the syntax, the tokens, everything needed to figure out the structure of a Ruby program.
And you feed this file into another tool.
Yep, you use a parser-generator. That's a tool that takes this parser.y definition file and turns it into the actual parser program.
And the source mentions the tools have changed. Ruby 3.2 used GuniBison.
Right, GuniBison. But after Ruby 3.3, they switched to a different parser generator called Ryama.
Ryama. Got it.
So Ryama is the tool now processing that parser.y file. And looking inside parser.y, YDAH explained its basic structure. There's an area for defining the rules.
The grammar.
Yeah, the Ruby syntax structure rules.
What?
And then another area for defining the tokens, the basic symbols. And it follows that Bison-like BNF format.
And that format itself. He showed an example, right? It didn't look too terrifying at first glance.
No, the basic idea is pretty straightforward. A rule has a left-hand side, which is just the name of the rule, like XPR maybe for expression,
Okay.
and then a right-hand side, which lists the sequence of tokens or other rules that make up that structure. Like a simple XPR might be just number, or it could be number plus number.
Right, just defining the allowed patterns.
Exactly. He even says it's not that difficult looking at just that simple example. And he clarifies there are two kinds of tokens involved.
Okay.
Termination symbols. Those are the basic bits you can't break down further, like a number literal, or the plus symbol itself. And non-termination symbols, those are tokens that are actually defined by other rules. They expand out.
Ah, so some rules build on other rules. Layers?
Precisely. Layers upon layers.
Yeah.
Now, okay, here's where it gets juicy. YDH acknowledges this term, often used for Ruby's parser, the Devil's Castle, or even hell.
Yeah, it's a bit dramatic, but...
But it points to something real. Why is it called that? It really does. It speaks to the reality of it. Ruby feels so flexible, so natural to write.
Yeah, that's a big part of its appeal.
Well, achieving that feeling, that flexibility for us as users, it requires an incredibly complex structure inside the parser pathway itself.
So the ease for the programmer means difficulty for the language implementers.
That's the trade-off, exactly. It's the cost of that flexibility. And the source gives us a pretty stark number for this complexity. The current parser pathway is roughly 16,000 lines long.
Wow, 16,000 lines just defining what valid Ruby code looks like.
Yeah, just the rules.
Yeah.
And he contrasts this with the number of distinct symbols, which isn't actually that huge comparatively.
Ah.
Yeah, like 162 termination symbols, the basic bits, and 303 non-termination symbols, the rule names. He even briefly compared it to PHP and Perl symbol counts.
Yeah.
And Ruby's in a similar ballpark there, so it's not the number of pieces, it's the sheer number and complexity of the rules combining them that makes it the Devil's Castle.
That 16,000 lines figure is something. He even challenged the audience to check the master branch themselves to verify it.
He did. Shows he's confident in that number.
So, okay, given this scale, this complexity, how do the experts even begin to make sense of it or organize a structure that huge?
Well, YDAH explains that Ruby's grammar, like many language grammars, uses a layered structure to manage this. Layering is key.
And why layering?
It's crucial for solving ambiguity.
Ambiguity, meaning times when the same bit of code could be interpreted in more than one valid way.
Exactly that. If the parser sees A plus BC, it needs rules to know whether that's A plus BC or A plus BC. Layering helps define that precedence.
Okay, so what are the basic layers he talks about?
He starts with two main ones, expression and statement. An expression is something that evaluates and produces a value.
Like 2 plus 2, or calling a method that returns something.
Right, and a statement is something that executes an action, like an if condition, a loop, defining a method.
Got it. Value versus action.
Pretty much. And often expressions are part of statements, like the condition in an if statement. But sometimes an expression itself can be treated as a statement. Think about an assignment like x equals 5. It produces a value, 5. But its main job is the action of changing x.
Okay, so there's already some overlap. It's a hierarchy.
Yeah, it's layered. But YDAH points out Ruby needs more layers than just statement and expression to handle its particular brand of flexible syntax.
Right. This is where arg and primary come in.
Correct. The arg layer, he explains, kind of sits on top of the expression layer. Its main role is dealing with method arguments.
Why does that need its own layer?
Because Ruby lets you call methods, often without parentheses. That creates ambiguity.
Like his example, fx plus y.
Right.
Is that call f with x, then add y?
Right. Or is it fsy call with two arguments, x and y?
Okay, I see. If you write fx plus y, the parser needs clear rules.
Exactly. Or his other example, put hello 1. Is that put called with two arguments, hello and 1? Or is hello 1 something else entirely? The arg layer helps the parser figure out, based on context and priority, that those are arguments.
So the arg layer is specifically for resolving ambiguities around method calls and their arguments, especially with optional parentheses.
You got it. It's crucial for that Ruby feel.
Okay, and then the primary layer, what's that?
Primary is the most basic level, the absolute fundamental building blocks.
Like what?
Literals, numbers, strings, true, false, nil, parenthesized expressions, array literals using a, hash literals using a. Method calls themselves are often primaries. And importantly, the receiver in a method call, like the object part of object.method, that object has to resolve down to a primary.
So the most elemental pieces that other expressions are built from.
Exactly. And even at this basic level, Ruby's syntax creates potential ambiguities that the primary layer rules need to sort out.
Like the ones he mentioned.
Yeah, like if you write kind class, is that the constant class, or is it maybe a variable named class being used in a comparison? Or in a rescue clause, if you have rescue my error if condition, is a an argument to rescue, or is if condition some separate conditional expression? The grammar needs rules at the primary level to distinguish these.
Wow. Okay, so you really see how Ruby's flexibility, optional parentheses, using keywords in multiple ways, forces the creation of these distinct layers. Statement, expression, arg, primary, each adds structure.
But also adds to the complexity of that parser.c file we talked about.
The devil's castle, right. So with this massive, layered, complex definition, how do people like YDH actually work with it? How do they improve it or even just understand it?
Well, he uses a really good analogy. It's like organizing really complicated code.
Okay.
You don't just leave it as a giant tangled mess. You refactor. You cut things out. You abstract them into functions or classes. You need to do the same thing with the BNF rules in parser. The problem is, traditional BNF is, as he puts it, kind of a primitive grammar. It doesn't have great built-in ways to express these complex abstractions cleanly, especially for Ruby's layers.
How standard BNF makes abstraction difficult.
Yeah, it can lead to a lot of repetition and make it hard to see the underlying patterns. Which brings us to the solution he highlights, something being implemented with Ryama.
The new parser generator.
Right, and the feature is called parameterizing rules.
Parameterizing rules, what does that mean?
He mentioned it was discussed last year, too. It's basically a way to make grammar rules reusable, like templates. You define a general rule structure, but with parameters, like placeholders. Then you can use that rule pattern in different places by passing in different specific tokens or subrules as arguments.
Ah, so like defining a function or a template in regular code, but for grammar rules.
Exactly, that's the idea. And the benefit, as he explains, is huge. It drastically reduces code duplication in the parser.me file.
Which must make it shorter.
Shorter and much more readable. You can see the common patterns more clearly.
He gave a specific example, didn't he? The command assign structure.
Yes, a really great one. This single structural pattern in Ruby's grammar actually handles three different things. Simple assignment, x, 1.
Okay.
Operator assignment, x plus 1.
Right.
And also endless method definitions. Def foo was 1.
Huh. They do look structurally similar on the left side, don't they? Variable, maybe an operator equals sign, then the value or body.
Precisely. Now, before parameterizing rules, you might have had three separate, somewhat repetitive chunks of BNF defining these.
Okay.
But with parameterizing rules, they could abstract the common variable operator expression pattern into a single parameterized rule. Then they just invoke that rule 3 times, passing in slightly different parameters for the normal assignment, the operator assignment, and the endless method def.
That does sound much cleaner. He seemed pretty excited about it in the talk.
Yeah, he literally said, "Isn't this amazing?" when showing the simplified abstracted rule.
Yeah.
And this process, organizing and abstracting the grammar, it isn't just about tidiness. He shows it actually helps reveal things.
Reveal things. Like what?
Hidden structures, or maybe subtle differences between patterns that looked the same on the surface but weren't quite. When the rules were all tangled together, these nuances were hard to spot.
Okay, give me an example.
He gave a fascinating one. They found a specific syntax error that was happening sometimes with operator assignment, x plus equals 1, at the pop level, within this command assign structure.
Right.
Because they'd already abstracted command assign using these parameterizing rules, the structure was much clearer. They could see the error wasn't just a random bug, but was specifically related to how the arg part, remember the argument layer, was being handled within that combined structure.
Ah, so the abstraction highlighted where the problem was.
Exactly. It showed that arg behaved, especially just in the operator assignment case within that structure. So the fix wasn't some broad change, but very targeted.
What was the fix?
As he explained it, they needed to adjust the parameterized rule. They removed arg from the general left-hand side definition and specifically added it as something that could be passed into the opassign parameter part of the rule.
Wow, that's a fantastic illustration. Organizing the grammar definition clarifies the structure and pinpoints where fixes or special cases truly belong.
Precisely. Things you just miss in this 16,000-line spaghetti become clear when you apply abstraction and structure, even to the grammar definition itself.
Okay, so let's bring this all together from YDH Talk. Ruby's wonderful flexibility, the thing we like as users, demands a really complex, layered structure in its grammar definition, its BNF.
Right. The devil's castle.
But traditional BNF struggles to express this complexity cleanly because it's, well, primitive.
Yeah. Lacks good abstraction tools.
And the work happening now with Ryama, the new parser-generator, using features like these parameterizing rules, is essentially about refactoring that devil's castle.
Right. Minimizing the structural complexity inside the definition file, making it more manageable, more readable,
while still keeping Ruby's external flexibility and hopefully improving the parser's stability and maintainability.
Exactly. That's the goal.
Did he talk about what's next? Future goals?
Yeah, he laid out a few things. He wants to improve the usability of these new Ryama features, like parameterizing rules. Apparently, they were a bit hard to actually use effectively in the standard library or inline contexts.
Okay, make the tools easier to use.
Which should allow them to simplify the grammar structure even further. He also mentioned working on adding node location information.
Why is that important?
For compatibility with the Prism interface. That's the project aiming for a universal Ruby parser, usable by various tools like linters, formatters, editors. Location info is crucial for those tools.
Makes sense. Ensuring the official parser plays nice with the ecosystem.
Definitely. And finally, he included some really nice acknowledgments at the end.
Oh, yeah.
He thanked the LRR parser gangs, obviously, and something called the Dragon Books Club. You gotta assume that's people deep into compiler theory, right? The Dragon Book being the classic text.
Ah, yeah, good point.
He gave a special shout out to Mr. Kaneko, who apparently helped him shape the talk's outline, and even discussed how Ryama, he also called it Yammer, sometimes might have potential beyond just Ruby.
Oh, interesting. Using it as a general parser generator.
Yeah, potentially leading to a different evolution than Prism, maybe? And he thanked his family, mentioning his wife Mato and wife Mahiro, which suggests really strong support.
That's great.
And there was that really poignant note about his father working on computers for a long time.
Yeah.
And how YH feels motivated to protect that legacy through his own work as a Ruby and Ryama committer. It really shows the personal connection.
That's actually really touching. Puts the technical work in perspective.
It does. And then he wrapped up with a little plug for the Ryama product itself, asking folks to scan a QR code and give the project a star on presumably GitHub or somewhere similar.
Nice. Gotta support the tool.
Absolutely. And that brings us pretty much to the end of our dive into this specific source material from YDH Talk on Ruby syntax.
Okay, so wrapping this up, what's the big takeaway from digging into this?
For me, it's that the Ruby syntax you enjoy, the stuff that feels natural and flexible, is actually built on this surprisingly complex, deeply layered grammar foundation.
Yeah, it's not magic. That grammar is rigorously defined by formal rules, like BNF, and it's processed by these really sophisticated tools, like Ryama now. The flexibility you get comes from intricate structure managed by dedicated people like YDH and the parser gangs, who are literally dissecting and reconstructing how the language understands itself.
It's a really powerful example, I think, of how diving into a specific technical source like this talk can reveal the immense engineering effort behind the tools we might take for granted.
Totally.
And it shows that complexity under the hood isn't always bad, right? Sometimes it's the necessary cost of providing that simplicity and flexibility for the user, as long as the complexity is being actively managed and structured well. Couldn't agree more. So maybe here's a final thought for you, the listener, to chew on. How does the fundamental structure of other programming languages you use, think about their syntax rules, influence how flexible or rigid they feel compared to Ruby?
Ooh, good question.
Or maybe just consider this, how acknowledging and actively managing deep inherent complexity like we saw here with Ruby's parser and the evolution towards tools like Ryama with parameterizing rules, how there's really a universal challenge anytime you're trying to teach any kind of robust, powerful, yet usable system.